This is our electrical panel, ELV panel. That's how it looks. Our ELV panel. That's how it looks. This is our analog meter. This is our functional or digital meter. This is our ammeter, analog ammeter, analog ammeter, analog ammeter. That is red, yellow and blue, and also voltmeter, analog. This one is ATS stimulation switch for testing when you are doing tests, generator tests, because this one is connected also with generator, which is automated. This is a capacity of our transformer, 16 kVA. This is transformer, 16 kVA. This is breaker connection to the transformer. Then the capacity of our ACB, it's a triple pole ACB. Capacity is 2500 amperes. This is our ACB. As you can see, it's showing on. ACB is on. This is when it trips, it will show here. Here it's when you are operating manually, off and on. This it's, you can see now it is in auto. When I change here to hand, it will mean that it will go off, so I have to operate with these two switches, but as per now it is in on mode or auto mode. This is our generator ACB. It's a 4-pole. The other one is triple pole, but this one is 4-pole ACB from the generator, fed from the synchronizing panel, breaker connecting, LV, it's not MV but LV1, and synchronizing panel, which is capacity of 2500 amperes, in comma to generator. It comes from the generator. It shows it is off, as you can see, off. The other one was on. This one is means indicate off. This one is trip. This one is a manual button for on and for off, while this one has no a selector switch for auto all, because it's already connected in auto. That's why it has no selector switch. This is the multifunctional from the generator. This one is, as you can see, the current is 0. Kilowatt is 0 because there is nothing which is coming from the generator, but it has a power which is fed to this ACB. ACB is already fed by the power from the supply company. Also we have this selector switch for voltmeter, selector switch for checking voltmeter. have ammeter, which is showing you the ammeters are off already. You can see also voltmeter is off. It is not off, but it has no any volt because already the generator is off. This power which is showing here is just for operating the ACB. Otherwise there is no anything else going on. You can see showing you the kilowatts is 0 and current is 0. This ACB is connected to this panel. We call it synchronizing panel. Synchronizing panel. We have 2 generators. So this one we call it synchronizing panel. I don't know whether you can see it all. The synchronizing panel. And we have 3 LV panel in our LV room. So this one feeds 1. You can see G1B. This one is G1. That one is G1B. So that one G1B is this one. G1A. This one G1A, which is connected to G1B. Then we have this one G2. Stands for panel 2, and G for generator. So this is B comes from connected to the panel and the MV panel, which is this one. This one is the panel 2. This is our panel 2. It has the same things which are connected, as you can see it. Here you can see this aluminium cover. Down there is a trench where the cable passes through. It's a trench. So we have generator 1. This is written generator 2. Our generator is of 2000 kVA. It's a diesel generator, which is fed. This shows fed from the generator. The incoming power, it's a 4-pin or 4-pin ACB. The capacity of this ACB is 32 amperes, not 32 but 3200 amperes. This ACB, and this is from the generator 1. As you can see, generator 1, 4-pin ACB, 32 amperes, 3200 amperes. That ACB. Now this one goes to the panel. This is panel 3. As I showed you, we have 3 panels, and this is our panel 3. As you can see, this is our panel 3, panel 2, panel 3, and panel 1 there, panel 1. So this is BL3, 3, 2 and 1, feeding to each different breaker. Then we have this one. This one we call it PLC control panel. This one is the one which is connected to our stimulator, which is auto, which is connected by our panels. This one is which makes all things auto. It's connected also with the BMS, which this switch comes from that panel ATS. So that our PLC is our ATS. All the things are connected there. All these ACBs are connected there to make our system automatic, to start generator or to stop it automatically, and also to start the power from the supply, or to stop it when there is low voltage, or when there is a high voltage, or when there is failure. It will start or kick on the generator. So that's how our system works. We have these panels. This is our battery backup. This is our battery backup, and fed for this relay RIF. When we have a earth fault, this one will automatically switch the system off, because it's already fed by the power from the batteries, and also is connected to the ACB. This is a relay. As you can see, it's written instantaneous earth fault relay. That's why you see it's written REF. So this is our relay. If there is a problem with earthing, it will automatically sense and it will switch off all the system. We have this one from the generator, and we have this one from the power supply company, which are all connected to this coil. This is our resistor. If you can see, our resistor is connected with the 2 power in and out to control our generator and also our supply company power if it has a problem. This is how the relay looks inside. These are the connections. These connections comes from here. You can see these cables comes here, and also these cables also are connected to this ACB. You can see these 2 cables going to the ACB, and also we have these 2 other cables going to this relay, and also connected to this ACB. So we have 2 connections from these 2. This one is for the generator, the other one was from the power supply side. This is from the generator. This is our coil, which is connected to this our ACB. You can see this is our ACB, which is connected here. This cable goes inside the ACB for the control is when there is any problem in power. That's how our system works to control our facility. Thank you for watching. Keep watching for more exciting video. Welcome, and always welcome again.